Hi, my name is Ashley Cohen. Welcome to BioVCN's Lesson 6 live coding demo. So today I'm going to show a short code I put together which deals with a very common sorting and data cleanup operation people do to their OTU tables. So an OTU, or an operational taxonomic unit, if you don't know, that's just the taxonomic designation of some item in your table. And oftentimes when you get below the phylum or order level, you quickly start multiplying the number of items you have, sometimes 50 to 200. But when we want to make plots or look at broader trends, usually we're only interested in, say, the top 20 or 30, or it quickly becomes very overwhelming. So in this script, I'm going to import a CSV file of OTUs from my own work at Fayetteville Green Lake. And I'm going to show you how to read in the CSV file and then combine all the discrete samples from a broad environmental zone I'm interested in, and then how to sort the data to retrieve the top 20 OTUs and calculate their relative abundances, meaning the fraction of reads of that OTU to total reads. So I'm going to launch the binder now. Okay. And what I'm going to do here is I am going to go to New Console here, Python 3. So I just have that open. And notice in the directory here, there's the script itself, relative abundance cleanup.py, and then the input CSV file. So let's quickly take a peek at the file that we're going to read in. And you can see here that we have all of our OTUs, and there's quite a lot. If we scroll down, this is what I was mentioning. So we have over 300 here. And then the column headers here represent each discrete sample in that broad environmental range that I'm interested in treating as a whole. In this case, it's my suboxic zone in my water column. Anyway, let's X that out and take a look at our script. So first I'm going to read through this code and explain what it does before I run it. And I've built in print statements along the way so that you can view and kind of understand more what's happening at each of the critical steps. And it's also a really good way to debug or trace if something's breaking. So here at the top, I'm importing some Python libraries I need. I'm importing NumPy as NP, and I'm importing CSV, which is a way that Python will let me read in a CSV file line by line. So let's go over how we read in the CSV file. With open, and then my file name, as CSV file, my reader equals blah, blah, blah. So what this is doing is it's saying with the file suboxic gl3.csv, which has a new line delimiter as our new line character as my file, this is going to be my reader, and the delimiter is a comma because it's a CSV file. Now notice here this line that says next my reader. That's because in this case, I want to skip the first line of the CSV file, which are all of the column headers, which I'm not interested in. And here I'm declaring two empty lists, taxa list for the OTUs and sum list, which will be for all the read totals. Now I'm going to take my reader and I'm going to iterate through each line. So here I've built in a print statement just so you can see that row when you run it. And then I'm saying taxa is row 0, right? So in that row, the item all the way to the left, or the OTU as we saw in the CSV file, is the taxonomic ID. So I'm then appending that to the taxa list. And then everything to the right of that, meaning the number of reads for OTU in each discrete sample, are the number of reads, right? So here I have a print statement that will show that when we run it, that says, okay, all the reads are starting from position 1 in that row after OTU ID and then go all the way to the end, right? Now, notice here I'm doing something which is I'm taking all those reads and I'm converting them to a float. And the reason I'm doing that is because when you read in a CSV file and it's mixed, meaning that it's numbers and strings, everything that you're reading in is a string. So if you try to total or divide or do any mathematic operation on a string, it will break. So what this does is it says, okay, X is every item in this list, which are all my reads. So for each X, for each item, make it a float, right? And then here, when we print float reads, we'll see that the string designators, the quotes, will go away. And then I'm saying, okay, now what I want to do is sum all of those reads for that OTU. So I'm just using the built-in Python function sum, and I'm summing the float version of the reads. And then I'm saying, okay, I'm going to print my total, and then I'm going to append that to my sum list, right? This line is a little more tricky. So this is sorting the number of reads in descending order, meaning that we want them to go from the greatest number of reads to the least number of reads. But the problem that you can run into is that if we have the separate associated list of the OTU IDs, we want to make sure that that list is being sorted along with it. So we need to do this to both lists in parallel, or OTU IDs will be out of order. So I'm using a little trick here, using the zip function in Python, which I'm a fan of. So when you use the zip function for two lists, you're treating them as two things to iterate over in parallel. And so here I'm declaring two variables, descending totals and descending taxa. And I'm doing this kind of broad list manipulation I did for float reads, where I'm saying do this for each item in the list, right? But in this case, I'm saying T instead of X, but it's the same idea. And I'm using the Python function sorted here. This is a nifty little trick. If you use sorted with an asterisk in front of it, you can actually enclose two zipped lists, which is great. But when you do that, you can't actually define any of the other arguments, such as ascending or descending order. So it will just do the default sort, which is ascending, which is why below I have dot reverse, right? Because I want to flip the order. So, and dot reverse, something to note about this Python function is it does the operation in place, meaning that it will alter the list. So you don't need to declare a separate variable. I don't have to do descending taxa equals descending taxa dot reverse. It will just do it. That's also something to bear in mind. If you need the original list for something, you should make a copy first. Okay, cool. So now we have our descending order OTU and totals for the combined samples. And now I want to retain only the top 20. So here I have two variables I'm declaring, top 20 taxa and top 20 totals. And I'm saying go from the beginning of the list, which I'm designating with the colon, until I get 20 items. So that will retrieve indexed list items 0 through 19. Now that we have our top 20 OTUs and the total of each one's reads, we can calculate the ratio of that OTU to all reads of all OTUs. So here I'm declaring an empty list called top 20 relative abundance. And I'm saying for T in top 20 totals, meaning for each item in my sum list, right? And I'm saying take T, take that total number of reads of that OTU and divide it by the sum of the top 20 totals, meaning all reads of all 20 OTUs totaled, right? So that's going to give me a fraction. And we'll print that out nicely in the print statements when we run it. So I'm saying make this calculation and append it to the list, right? Okay, so now we've done all of our calculations and we want to output that information as a CSV file with headers. So I've made a list of strings here for my headers called my out headers, right? Self-explanatory. And then I'm saying with open out file name, basically, as the type W or write file, as file, I'm making that my writer, and then I'm saying I want my delimiter to be a comma because I want it to be a CSV. And then the first thing I'm going to do is I'm going to write my header row. And then I'm going to go iterate through my list items and output line by line. So here I'm saying for I in range lin top 20 taxa, and then I'm saying each row will contain the following: top 20 taxa, total, rel abundance, and in each thing I'm saying I because I want it to go over each list item since we're outputting line by line. And notice for top 20 relative abundance, I've had to enclose that in string, and that's because it's a float. So I make this my out row, right? And then I say, okay, write out row. And that is the whole script. So now that I've explained what this does, let's actually run it. So I'm actually going to go to the console here, and I'm going to do run rel cleanup.py, shift enter. Which doesn't, okay, I'm going to have to relaunch my console. Sorry, guys. So now we can see all of these outputs. It's a little overwhelming, but I wanted to show how it works. So let's just look at one of these. So I'm going to go up to the beginning here, right? So this is all of the importing. So you see what it's importing here, line by line, right? OTU, and then the number of reads in each of those 4 discrete samples. And then I have all my print statements like, okay, this is the taxa, this is read string, which you can see enclosed in those quotation marks. Float reads, which you see those quotation marks have gone away. Total. So I'm now gonna skip over the rest of these because that will take forever to go through, but I just wanted to show everyone how that works. There's a lot of these. Okay. So here we're seeing an example of the math, right? So this number represents sum totaled number of reads for one of the OTUs divided by total, and then that relative abundance number, right? Again, this is a good way to debug if you see something that doesn't look right. Okay, and then now let's go to what our output will look like. So here is each line that we output, right? Which includes the taxonomy, a comma, because it's a CSV, total number of reads, comma, and then absolute, and then a relative abundance. So now if we take a peek at our output here, we get a nice CSV table that is in order. Notice that that sorting has held up. So it's going from greatest number of reads to least, which is great for plotting. You know, if you're plotting relative abundance and you want to show it in, you know, ascending or descending order along an axis. And then you have your OTU and the relative abundance. So that has worked great. And that is it.